Understanding the OAuth framework doesn't necessarily have to be complicated. It's just a matter of orchestrating among a few components we are already familiar with. The majority of this story is very simple and fun. Please allow me to show you how. This is the RFC of the OAuth framework. If you're new to the framework, this gives you a clear direction on the map. Just keep the RFC aside for a moment. We don't have to drill down to its technical depths just yet. But it will be a whole lot easier when you come back and look at it on the second time once you see the big picture and also see how it works in action, which we are about to do it here. The most prominent flow is here, the authorization code flow. Once you understand how it works, the rest of the flow is just a matter of tweaking the core concept. RFC explanation is marvelous. Each step A, B, C, so on and so forth are well explained below, but what's missing are animations and a live demo. Without further ado, let's see the complete workflow from start to finish. After that, we'll zoom in each component in details. Now, step A. Web server redirect user agent or web browser to an authorization server. Then a user, typically a human, will have a chance to enter their credential. If the authorization server happy with the credential it has given, it will redirect the user agent to another URL of the web server. That URL is called callback endpoint. How does the authorization server knows where the callback is? Keep watching and we'll get to that point together. For now, the authorization server isn't only just redirect the user agent back to the callback URL, but also it gives something to the callback endpoint as well. The most important one is the code, or technically it's called an authorization code. This authorization code is not the resource owner credential. It is not something we can use to present to any other components except the authorization server itself. What we need ultimately is an access token where we can use it to access a protected resource. Or simply, you can think of a protected resource as APIs that we can call it, but without a token, the request will be rejected as if we get into a bus and we don't have a valid ticket, or we can call it a token, then we're not allowed to use the bus. Now, at this point, how can we get an access token? Well, we can use that authorization code to trade for an access token. Please note here, the trading of an authorization code to an access token happens on web server side. The user agent and its host have no way of knowing anything about an access token. Great, but why does it have to be this complicated? Why doesn't the authorization server send an access token on step C in the first place? Yeah, that's right. It is possible, but imagine if your device was infected by malware and it is able to access your web browser data, or any misbehaved JavaScript library which is able to steal any data, then an access token will be under a security risk. Now, once the web server gets an access token ready, it can be used to access a protected resource as usual. Those yellow boxes you see there represent a scope. I'll explain it shortly. Let's see everything we have talked about in action. Now, let's time travel back to the beginning. Firstly, we need an authorization server. I'm going to run Keycloak inside a virtual machine locally. When it's up and running, let's check the endpoint. As the log shows here, I'm in the admin console. The username is the admin and the password is also admin. Now, the authorization is up and running. Time to redirect the user agent to an authorization endpoint as to what step A does. Here is a client code implemented in Golang. I'm going to run it up. Here is what inside the main.go. It isn't interested at the moment. Let's run it. As slide 74 shows, it listens on port 8080, so localhost 8080. However, the project doesn't map the root path, so navigate to the /home. Great, our client is up and running. Now, Let's see step A in action. Login. See, it redirects user agent to the authorization server. As we can inspect the URL, it is indeed the IP of the box. Now, resource owner has a chance to fill up their own credentials. We can see a list of users here that Keycloak knows about. There are 2 users here, Bobs and Shanalong. I'm going to use Bob for now. The other user comes from GitHub OAuth application, which we're not going to talk about it here. Here's what's about to happen. The authorization server will redirect user agent back to the application callback with an authorization code once I hit the login. The client server log shows details about the redirection and its URL query for this demo, and for simplicity, I choose to show those sensitive data out loud just for learning's sake. See that it's print out an authorization code and access token as well. What we have seen in the web UI is the results of step D. This endpoint, the auth code redirect. See that we extract an authorization code that we will use shortly. This one, the exchange token, grant type is authorization underscore code, exactly as per IFC defined here for default. Redirect underscore URI, client ID is where we register this application to the authorization server at the beginning. Code underscore verifier is about the proof key for code exchange, or PXE for short, which is not relevant here just for now, but PXE is what best practices are suggested to do so. The basic auth is the combination of the app ID and app secret, which we can get it from the Keycloak. Here and here accordingly. Once the exchange is done, we get an access token like so that we can use it to access a protected resource as usual. Let's access the service, which will make a request to the protected resource behind the scenes, and it should work. Nothing happened. Context timeout. Right, because I haven't run the protected resource yet. Let's do it quickly. Before that, let's see what the building service is going to return. Here, a list of facilities that we have to pay the bill in JSON format. Token introspection is one of the authorization server endpoints where the protected resource will use to send an access token to validate its validity. Now, round it up. Service again. Invalid token. Alright, maybe the current access token is already expired by now. Let's get a new one. This time, we don't have to log out and log back in from the beginning. Instead, we can also use the refresh token as well. Let's refresh the token. Now, not only we get a new access token back, but we also get a new refresh token as well. Time to try to access the service one more time. Awesome. That is an overview of the authorization code flow from square one, with a live demo shows exactly what each step in the RFC diagram has described. There are many nitty-gritty details behind the scenes. If you like to have that sandbox available to use at any time on your machines to experiment concepts that concern you, and also want to develop every project you see in this video from scratch, then I'm more than happy to help you out. Please find more information on the link under this video. It will land you to my GitHub page. It's always the lowest price available here, and I'll keep it updated regularly. If you are watching this video, you're probably interested in this course, the OAuth 2 Nail the Core framework with hands dirty. In this course, full fun parts are packed for about 6 hours. Don't take my word for it. Just look around the course and enjoy the contents. See you there.